Okay, hi, I will go and explain you the slush activated process team. And first, in the operating principles, I have to say that in the industry, the terms of primary effluent and the secondary effluent are commonly used to refer the flows that is going to incite in this slush activated process. So, the first step of this slush activated process consists in this primary effluent that is going to incite in a biological reactor. Inside of these reactors, we have a mixing of microorganisms, biodegradable or not biodegradable suspended matter, colloidal matter, and the result of all this mixing is known as mixed liquid. So in all this process, it's so important the aeration process. For that reason, we need an aeration tank. Over here in this place is produced an oxygen injection who is responsible in the activation of the microorganisms that are assuming the organic matter of the water. And finally, we have a sedimentation tank in the sedimentation process over here, that here is produced the separation of the suspended solids to achieve the clarification. Here we have the design parameters, but I will only explain the conventional process with these parameters and the allowable range of each parameter. For that reason, we have first the food microorganisms radio, second we have the volumetric load, third we have the detention time, the slush age, and finally the volatile suspended solids. Here we have the design equations to calculate the parameters previously explained. First we have the detention time that will be equal to a 24, that will be a conversion factor 2 hours, multiplied the relation between the tank volume between the flow. Second, we have the food microorganisms radio relation that will be equal to a wastewater flow multiplied the BOD5 concentration in this wastewater between the liquid volume in the aeration tank multiplied the mixed liquid suspended solids concentration. I decided to show you the slush age equation, but this parameter I will going to assume because effects of design for this case. And here we have the equation of reactor volume and the volumetric load. The volumetric load will be equal to a BOD5 concentration in kilograms plus the flow between the reactor volume. And the reactor volume, we're going to use this equation that where we are going to use the parameters previously explained and calculated. So, for example, here we have the slush age, here we have the flow, here we have the concentration of microorganisms, that is another parameter that we are going to assume, like the slush age. Here we have the hydraulic retention time, we have the influent substrate concentration, the bacterial growth of production coefficient, and this mode we calculate the reactor volume to the design calculated. So this is all. Thank you very much.